Okay, I don't know. Anyway, let's see what this one is. This is 5.246 in the book, number 16 online. First of all, is it a test question? No, not really, because I don't want you to have to do this one is an easier test question because they only give you 30 and they give you a class width of what? 10. I'm not going to, if I give you one like this on a test, it'll be like this. It's not going to be 28.7 and a class width of 3.6. Okay, I'm not going to do that because that takes too long. This one, you can sit here and go 30. Well, tab. You're supposed to be able to go down, but I don't know why it's not going down. 40, 50, 60, 70, 80, and 90. Okay, now y'all fill in the other side. I'll start recording. Oh, I am recording. Okay. So the next one is going to be, what comes before 40? 39. Y'all are so special. 39, 49, 59, and so on. Whatever, I'm not going to type it. Good gracious. It's supposed, the arrow is supposed to go down. I don't know why it's not working. 69, I have to hit the mouse. 79, 89, and what? 99. Now let's take this over to here is the handy dandy, I'm going to put it in the Excel spreadsheet. And I'm going to show you a trick I learned in the war. And y'all can use it if you want to. I should have showed you this the last class, but go ahead and put them in order. And hit sort. And let's go ahead and count them. So let's go ahead and put what did it say, 30, 40, 50, 60, 70, 80, 90, is that it? And then 99, 89, 79, 69, 59, 49, and 39. And now we're going to count. So 36, 30 to 39 is what, 1? So we're going to put a 1 there. Okay, we got to fix this. I can't take this. I got to fix it to where we're all in the middle. I'm sorry. Not OCD, just gets on my nerves. Insert. There we go. This is your lower class limit. This is your upper class limit. And this is what? What's the variable? The F or X? F. Thank you, one person. All right, so what's 40 to 49? How many? 1? And 50 to 59? What is that? 3? Y'all check me, please, because I'm doing it by eyeballs. 60 to 69? 1, 2, 3, 4. 70 to 79? How many is that? 70 to 79. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Y'all check me. 80 to 89. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And what's the next one? 98. So let's check to see how many is in the whole shindig. Should be 40. Okay, 40. So that's n. Let's go ahead and say n, or summation of x is equal to 40. Summation of x, sum of f, sorry. sum of f n is equal to 40. Now, of course, you can do it by hand, but over here, you can actually pull up average. See that right there? AV, average, and down at more functions, you can pull up ST. Okay, why isn't it pulling it up? STA. It's supposed to pull it up. There it is, ST. Standard deviation, you can use that. All right, so average and standard deviation are right there. I don't know if it pulls up the variance, but you can type in V and see. No, it's not going to let me, but V. I don't know why it's doing this. VAR. There's the variance right there. Yeah, this variance earlier estimates variance based on sample. So you can do that if you want to. So, but you got to have two columns. I would assume you have to go ahead and find x, which is your midpoint. So x is equal to parentheses this guy plus this guy divided by 2, and then copy that down. And any of your computations are going to be using these two columns. So those are the two columns you're going to be using. You're also going to be using this one. That's going to be used in your formula also. So I don't know. I guess we can. I'm just going to do it by hand. So I'm going to do f times x right here. So I'm going to put f times x. And then I'm going to go down here and I'm going to say equals f times x and enter, and then copy down. Now I'm going to skip a few steps here because this is Unit 1 material and y'all should be able to do it. F times what right here? X squared. It's going to be right here, so that's going to be equal to, now watch what I do here, F and then times, oh, horse buggy. Hold on a second. Let me just restart that. You just have one of those days where you just can't type anything, you can't write anything, you just, okay, F times, and then hit that, and then raise to the what? Second power. And y'all check to make sure that that's the correct number. And what do we do with both of those? We get the what? Control C and Control V, Control V. Now that's all your numbers you need. That's it. I kind of condensed everything, but you should be able to do that now. Now I'm going to put it in the formula. What's the mean? The mean is equal to the summation of f. Which is the summation of f? I mean f times x. Right here, divided by that right there. Are y'all paying attention in Oconee? I can't tell. Looks like one of you's on your phone, the other one's doing whatever. Are y'all following along or what? I'm just needing to ask you.
Yes.
Okay. All right. Standard variance is equal to, and that's where we got to pull out all the. So n, I'm gonna write it out, and then is that number right there times what? The summation of what? The summation of f times x squared, right? Minus. Now, if you have no idea what I'm talking about, you need to go back and get the formula because I told you to read the formula. equals the summation of f times x. And then what do you do with that? You raise it to the what? Second power. All that over n times what? N minus 1, Hubert. That's right, class. Okay, now I'm going to actually calculate it. So 40 times whatever that big number is right there, is that big number, minus this number raised to the second power. And what did I tell y'all about these two numbers? Which one has to be bigger? The one on the left, because then you'll have a negative and you can't take the square root of a negative. So if you get a BA number right here that's bigger than this number, you've done something what? Wrong. And 40 times 39. And I'm going to do the actual calculation. And this is the variance, remember? The variance. So that's equal to, I'm going to put it in parentheses and do it in one step. This minus this, close parentheses, divided by this. And that is your variance. And what is the variance? I mean, what is the standard deviation? The what of the variance? Exactly. So I don't know what they're asking for in this problem. I'm just doing everything because what we did last time.
One message coming in on
Raised to the 0.5 power. All right, write those numbers down, please. 207.6282 and 14.40931 and 76.75 is the mean. I have no idea what they're asking for, but we'll look at it. Oh, why I'm looking at it, what does the curve look like? Looks like to me it's going to be skewed left because most of your data is on the what side? The right-hand side. So it's skewed left. The mean is 76.75. The variance is 207.6282. And the standard deviation is 14.40931. Let's go back to the question now. Oh, give me the, did y'all write down the numbers? I'll do it, because then I would have to ask y'all to interact. 1, 1, 3, 4, 13, 10, 8. 1, 1, 3, 14, I done forgot.
10, 8.
Thank you. 1.
That's the relative, though. It's gotta be
Oh, shoot, we got to do that. Got to do the relative frequency. And what is the common layman's term for the relative frequency? The percentage. So right up here, put percentage. Percentage. That's the 25-cent word for relative frequency. So 1 divided by 40, block 40, F4, and then copy down. Now somebody write those down for me, please. 2.5%, 2.5%, and you can put them as decimals or you can put them as percents, whatever the directions say. Color that a dark green because that's what they're asking for in this problem. There we go. Got those. All right, so let's go back to the question now. 0.0025 is the first two. So 0.025 is the first two. What's the last one? I mean, the third one.
0.075.
0.075. What's the next one?
0.1.
0.1. The next one.
0.325.
Next one.
0.25. 0.2.
Point what?
2.
And check answer. And you should feel good about yourself. And then it asks for which one's skewed left. B. Final check. Fantastic. Determine the mean and the median. Now I didn't do the median, but what is the mean? It says type in, somebody give me the mean.
76.75.
70 what?
76.75.
And did anybody do this on your calculator? I'll do that. I wonder if I do everything. Let's see. Stat, edit. Is that the same numbers? Check and see if that's the same numbers. 13, 10, and 8. Is it?
Yeah.
Okay, so hit stat. Well, I didn't know we did this. I thought the numbers may be different. Calculate, first variable stat, L1 and L2, that's normal. And of course, there's the median, 74.5. What was their mean? 76.75, is that what I got? Mm-hmm. And SX, 14.41, is that the standard deviation? 14.4093. Let me see what I got.
That's what you got. You have 14.4093.
Yeah. Okay. So let's go ahead and put those in the answer. So 76.75. What was it? 74.5 was the mean? 75. Check answer. Was it 74.5 or 75 point?
It's probably 0.5.
Well, I appreciate your input, Mr. Owens, but we got 13 other people that can say something.
0.5 and it still counted there wrong.
78.125. How did we get that wrong?
This happened last time you did this question.
74 point. Let's see what they're doing.
Shit.
I mean, I'm putting it in the calculator. What else do I need to do? I mean, let's see what they do. I'm glad I didn't put it on the test. Because we did that. Histogram, I don't care about that. Determine the mean. Okay, so here's their explanation. Enter the given scores into a calculator. The mean is 78. That's their explanation. Thank you very much.
I hate this question.
Well, actually, it's very good. It's just some of these questions. This question I've never seen before. Okay, forget that. I'm not going to worry about that. They're not. I think the reason I'm not worrying about it is because I don't think they're doing it the correct way. Because even the calculator, did the calculator get the same as I got?
Yeah.
Okay, my answer is correct. I don't know what the hell they're doing, and they don't even show you.
What was your, what?
Excuse what?
Yeah, you're fine.
Determine the sample standard deviation. Oh my God. What was the standard deviation? Somebody tell me.
14.
I got 13.34.
Well, I got 14 point something, and the calculator got 14 point something. Let's see what did I get? 14 point what? 14.4. And the interquartile range. The interquartile range, you have to subtract the third quartile from the first quartile or whatever. Good gosh. Hold on a second. I've never seen this question before. I'm glad I didn't put it on the test.
It goes till H.
Oh yeah, this is the one that goes to freaking Z. Interquartile range. Hold on a second. I think you take the third. It's the third minus the first times the interquartile range or something like that. I'm just pulling it up so y'all can see it. There it is. Q sub 3 minus Q sub 1. That's the interquartile range. So write that down. You take the third quartile and minus the first quartile. So let's go back. Let's go back to your handy dandy calculator. What's the third quartile? The third quartile is 84.5. Write that down. The first quartile is 70. That's the class width, which is 10. What? I guess. I'm trying to find the question. The interquartile range is 10. Okay, how did you get 13.74?
That's what it did.
That's what my calculator said. But the interquartile range is trying to say it's 15, but that's not what my calculator said. I got something else.
Okay, how did your calculator get 13 and mine got 14?
I used the calculator online. I just entered in all of the data sets, and that's just what it gave me.
Then mine are a few numbers off from yours, but it's still the same.
Okay, something's quirky with this because, okay, let me ask you, somebody, forget about the online. Has anybody got a TI 84 or 83 and punch these numbers in? What did you get? Can you punch me in for me? I need to get some kind of confirmation on, am I punching in something wrong, or I must have a number in wrong. Well, something's wrong because she's getting one thing and they having another thing, so we've got something wrong somewhere.
Yeah, I've got.
We got this right. So if we got this right, how can our numbers be wrong? Did we not get this right?
That's right.
Uh,
Oh,
where
that's right.
you do calculate, take the L2 off. Maybe that'll change it.
Well, it can't calculate the L1. It's got to have, the formula has got to have X. Hold on a second. Let me go to stat. I'm gonna go to edit. I want y'all to check my numbers and make sure I got them in right.
See, on mine, I just have the counts and L1. I don't have the midpoint.
You got to have the midpoint for it to do it. So you just did L2?
I just did, like, my first L1 column is all the numbers. And
Stat, calculate, first variable stat, and you just did L2. Second, or blue, L2. Am I not hitting the blue button? There. Delete, and then I don't see how you can just leave it blank. I guess you can. That ain't right. You can't do that.
I'm saying, like, the only column I have in it is the test scores.
Wait a minute. I think I know what's wrong. I think I'm hitting the wrong button. You got to hit, since it's two columns, dumbass, you got to hit second variable. There it is. My bad. Second, L1. Now calculate. Somebody check to see if, no, that's not it. I have no idea, y'all. I have no idea what's going on. I'm going to have to figure it out. That's all I can say. I don't, at least you know it's not on the test. I don't understand how you get 13 and I get 14 and we typed in the same numbers. That's what I don't understand. Did anybody else get 13 for your standard, or whatever, the mean or the standard deviation? Anybody?
Yeah, I did.
You did. All right, well tell me this.
See, if I go to my list, my L1 is just the test scores, like
Not the test scores.
midpoint.
You're talking about the head count.
Yeah, it's all 40 of those, and it's like there's no midpoint, there's no frequency L2.
So you just reading L2 is what you're reading.
Yeah, instead of one.
So you just typed in right here, 1,
No,
1.
I typed in every test score. So the 30, like the lowest score was a 30. Hold on, I can look it up.
You're talking about the lower class limit and the upper class limit?
No, it started with 36, and then 47, 55, 59.
Oh, you just typed in the test scores.
Yeah, and that's it.
Okay,
And it gave me
okay, then that makes sense. That makes a whole lot more sense. Well, I ain't doing all that. So, okay, this is what you do. Type in, there's another way you can do it, doing it this way, but I'm not going to try to figure it out. 34.5 and 44.5. There's a way you can do it, but evidently I'm not doing it right because I'm coming up with a different standard deviation. So what I suggest you do, I think you sent this question, Ms. Blackman, is type in every single test score, all 40 test scores on this first column, and then do linear regression. That's the only thing I know to do. I don't know why you get. And verify this. I did get.
in Excel.
I got the same thing, did I not?
Yeah.
Okay. Something is quirky with this question because I'm doing it the way that it's supposed to be done. The calculator is getting a different answer, and they're getting a different answer. So there's something not right with this question, or maybe I'm just crazy. I don't know. One of the two. Could be I'm just crazy. I'm going to type in L2 again, second, L2, and calculate 76.75, 14.409. And that's the same thing I got when you do it by hand, the way you're supposed to do it. So I'm confused. So I don't know what to tell you. The good thing is it's not on the test, because I think this is a new question and could.
That's what it is. Because just looking at the test scores, my numbers are different. My first one.
Okay, so you doing it different now?
Well, no, my first set of numbers is 36, 47, 55. Like for yours, you don't even have 47 or 55.
Yeah.
So we just have different numbers. That's all.
Okay, let's go on to something else. I don't want to take. I would highly suggest that you do it by hand, but I want to get the homework question right, Ms. Blackman. Type them all on the left column, L1, and then put those numbers in, because they're doing it data table wise, okay? But they're telling you to make a what? What did they tell you to make at the top? A frequency distribution. So you can't have your cake and eat it too, all right? Unless, wait a minute, do they say on the... Okay, let me just say this. What they should do right here is they should say determine the sample, standard deviation, and mean and all that by the test scores, not the frequency distribution. Does that make sense? Because what they're doing in this question is they're giving you a frequency distribution, they're telling you to make a frequency distribution, and then they're giving you the answers to the data instead of the frequency distribution. Does everybody see what I'm talking about? Oconee, do you understand what I'm saying?
Yes.
One person out of 4. Okay. All right. So I'm going to chalk that one up as the question is, it's giving you one thing and it's asking you to give you another, but it's going back and asking for a data-driven mean and standard deviation versus a frequency distribution. So it needs to make up its mind which one it wants. That's all I'm going to say. Okay. Next. I'm just going to go do homework questions. I'm going to do more homework questions. So that takes care of that one. Really doesn't take care of it, but does the best I can do in a limited time. So that was, okay, Mr. King has done sent some, but which one was that one we just did?
I think you already deleted.
Was that number 16? Yeah. That was number 16. And this is, oh, these were old. Okay, 5.2, number 4, number 4, number 4, number 4, number 4,
I think that's the one you said.
number 4, number 4, number 4. I'm just making sure they all say 4 before I delete them. 4, 4, 4, 4. Everybody sent number 4. 4 and 4. Okay. There's number 4. So we'll do number 4. Which one was number 4? Tell me if we've done it before. We did this one. We already did this one. Okay? So let's delete all those, please. Number 5, I think we did one like that one too. Yep. We did one like that one. Number 5, number 5, number 5, number 5. I don't know. He sent them over and over and over, didn't he? Okay. Up takes care of all those. 5.3, number 9. Let's see if we did one like that one. Yeah, we did one like this one. We did that one. 9, 9, 9. Okay, 10. So we get rid of these two. Number 10. Did we do that? We did one like that one. Number 11. I think these are new ones, the ones that we haven't done. Yeah, all those are the same. These, I think, is the ones we haven't done. Number 12. Yes. For a parallel structure of identical components, the system can succeed if at least one of the components succeeds. Assume that components fall independently of each other and that each component has a 0.25 probability of failure. Complete parts A through C. Would it be unusual to observe one component fail two components? It would not be unusual, okay? Because they give you a 0.25 probability. And to talk about what's a 0.25 probability, that's a 25% chance of failure. Okay, anything over 5%, and write this down, I told y'all this before, anything over 5% is very plausible because 95% of the population is going to fall between two standard deviations. And that leaves what? 95%, what does that leave? 5% is unusual. So anything over 5% is going to be feasible. So 25% is feasible, so that's why it would not be unusual. Okay? It would not be unusual, blah, 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 because 25% is greater than 0.5%, than 5%. That's where that comes from. It would not be unusual to observe two components because 0.0625 is greater. Now, how did they get 0.0625? They took 0.25, and what did they do to it? Squared it, because it said how many? Two? Did it say two? I can't read the question. Two components right there, A. So you take 0.25. Now, what tells you to multiply? There's a word up there. What does it say? No, up there, well, yeah, you could say, I don't even see and, but up in the top right-hand corner. Fail what? Independent. When you see the word dependent and independent, what did I tell you that meant? Multiplicative rule. Write that down if you haven't already. Multiplicative rule, right over that word independent. Independent and dependent means that you're dealing with multiplication. What is the probability that 2 will succeed? Well, what's the complement of 0.0625? What's the complement of 6 cents? 97 cents. No, 0.93 cents. Thank you. So that's the complement, 0.9375. How many components would be needed in the structure so that the probability of the system will succeed is greater than 0.9999? Well, you would have to find x, you would put x in for the variable. Yeah, because you're multiplying. And 0.9, let's say parallel structure to succeed, how many components would be needed in the structure so that the probability of the system will succeed is greater than 0.9999? You would set 0.9999 equal to 0.9375 to the x power. And then take, let's see, then you would, they want you to use algebra. I don't think they want you to use algebra on this one. Let's see if they want you to use algebra, because you're going to have to do that. That's what you're going to have to do. And we haven't covered algebra yet. I'm getting to that point. I want to make sure they're doing algebra, if they're doing algebra or not. Okay, they're doing the multiplicative of algebra. In other words, multiply it out times x. Yeah, that's what they're doing instead of the x power. Yeah, 1 minus x. Well, there it is. There's the x power right there. They just put in. But that's still going to be using the algebra. Using algebra. They are. And you're going to have to take the nth root. 1 minus 0.27 to the nth power is equal to 0.9999. Never covered it. See, there it is right there. 1 minus 0.27 to the is equal to 0.98. Okay, they're doing trial by error. That's what they're doing. They're doing trial by error. I knew you couldn't do that because you'd have to use the natural log. To solve this equation right here, you'd have to use the natural log. So what they're doing is they're telling you to punch in, 2 successes, so they want you to punch in 3, 4, 5, and 6 until you get this trial and error. I was beginning to wonder, you don't even know what natural log is in this class. I mean, you might know what natural log is, but the only way to get that x power down is to do the natural log of both sides. So what they're doing is trial and error. So what you want to do is type in the 1 minus, and it would be, they're doing it a different way. They're doing the complement. So that's going to be, in this case, 0.0625. Raise that to 1 minus that to the third power, 1 minus that to the fourth power, 1 minus that to the fifth power, sixth power, seventh power, until you get what? Greater than 0.999, and that's going to be to the fifth power. So the way that you would do that, and I'm just going to draw it up here because The reason it threw me off is because I'm used to doing that with algebra, and we haven't had algebra in here, and that's what threw me off. And it's very kind of going backwards to tell students to do trial and error, and that's why it kind of threw me off. We know that you've already done it 2 times. Somewhere up here it says 2 times, right? We know 2 times. What was the success rate of 2 times? Okay, 0.062. There it is. Okay, so 1 minus 0.0625. Okay, and you're going to raise that to the second. 1 minus 0.0625, you're going to raise that to the third. 1 minus 0.0625, you're going to raise it to the fourth. 1 minus 0.0625, you're going to raise it to the fifth. And one of those is going to be greater or equal to 0.9999. This is not a test question. I know why y'all sending these questions, because it looks like to me these questions are new. Especially when they ask you to do something about trial and error. That's ridiculous. 5.3, number 12, same type question. I'm not going to worry about that one. I showed you how to do it now. That's the same question. Let's move on to 5.5. Maybe there's some sensible questions in these. Number 12. Suppose Grant is going to build a playlist that contains 14 songs. In how many ways can Grant arrange the 14 songs on the playlist? Grant can arrange the song, well, that'd be 14 factorial, would it not? Because they don't give you anything else. They don't give you, so let's do 14 factorial. 14 factorial, math, probability, and factorial, and enter. Yep. So you would have to write that. Now, let's go over scientific notation, because this is what y'all do, and not y'all meaning everybody in this class, but students. They'll type in, you know, they've had scientific notation in high school, they've had scientific notation in biology, chemistry, and math. And then the calculator spits this out, and what do y'all do? Y'all stare at it. And then you turn to the teacher and go, I have no idea what this is. Yeah, whatever. So let's do what it says. 8.71782912 and 10 decimal points to the right. 1, 2, 3, 4, 6, 7, 8, 9, 10. There's your answer. My calculus class, I told them to put something in the calculator the other day. Calculus now, I teach calculus. And they punched it in, and I had 2 or 3 students say, this is what it's got. And I'm like, you're a failure. You're a disappointment. You're in a calculus class, and you don't know how to read scientific notation. But you admitting that means a whole lot more than, this is what it says. That's something I would expect out of a pre-algebra class, or a student in a basic math, or a pre-algebra, but a calculus class, this is what it says. Is that a delayed reaction?
Yeah, I was busy learning.
Oh, you were busy learning. You were focused,
I
right?
was focused.
I'm sorry. This is not the best set of questions. Now, that's a test question. So remember, what kind of test questions do I like on a test?
Short and sweet.
Short and sweet. This A through Z, no. Okay, so that's that one. That's a good test question. remember, if they don't give you any other information except for 14, chances are it's going to be 14 factorial. Okay? Let's delete that one. Let's delete all these, please. Shift, delete. Next one, 5.5, 17. And this is a test question. How many different 10-letter words can be formed? Always remember this. Smile. Now, how many different arrangements can I make out of smile? Well, how many letters do I have? 5. So that's going to be 5 what? Factorial. So, how many different 10-letter words? Now, I don't like, okay, they did put real or imaginary. Why do I not like when they say 10-letter words and don't put that? Why would I have a problem with that? Because Kikubiwi is not a word, okay? Okay, so since they did put real or imaginary, how many letters do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So go to it. 10 factorial. What is 10 factorial?
3,628,008.
Well, okay, then we're missing something. It shouldn't be. It shouldn't. Today's just a bad day. 302. 10-letter words. How many we got? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I have no idea. I'm going to check 10 factorial again. I'm going to hit second, enter. Okay, turn it on. Second, enter, and change that to 10. $3,628,000. Let's see what they're doing, because smile, that's what I always fall back on. When they're talking about words, you take the number of letters and you... Oh, they're using the permutation. We didn't cover this. We didn't cover this, so write it down. You got to count how many. We didn't cover this. Count how many are repeating. Okay, you got 1, let's see, how many are repeating? There's 1, 2, 3, 4. You got one that's repeating. I think that one's going to be 4 factorial. See how many are repeating up here? 1, 2, 3, 4, 5. See there? That's 5 factorial. We haven't covered this. So that's how they're getting this. But how do you know this?
Now I got an answer.
I don't know how we're supposed to know the difference.
What if 2 of them are like 2 factorial? What if
You
2
do
are
10
twice?
factorial divided by
Yeah, it would be 2. If there was 2 repeating, I think 2 repeating, you would have 2 factorial with it. But 1 factorial is not the problem. The other one's the problem. So it's 10 factorial over 5 factorial. So we had half of it. We just didn't have the other half. But I don't know. This is not a test question. I thought it was, because there's nothing in the directions to tell you to do this one different from smile. So another question that I haven't seen before. I love how they throw these new questions in on us and we don't know. Okay, so that's not that'd be 10 factorial over, how many's in here? 4 factorial. So 10 factorial over 4 factorial.
And it gives you that answer.
Thank you. Not a test question, but that helps you, Ms. Blackman. The only thing that bothers me about that question is there's nothing in the directions to tell you to use the factorial formula. There's nothing about repeating. The only thing, this is it. Okay, smile doesn't have anything repeating. That's why. Okay, usually they give you a word like smile or king. Okay, they don't give you BGG. They don't give you that. New question. Let's do something different. This is number 18. A golf course architect has 4 linden trees, 5 white birch trees. Birch is the ones that peel. You know, the ones that have the peeled bark off of it. Beech is the one you carve your name in. And 2 bald cypress trees to plant in a row along the fairway. This sounds kind of like the main course. You know the main course in the dessert? 4 times 5 times 2. Sounds like it, but I don't know. How many ways can the landscape plant the trees? Oh, it's more than that. So let's plant the tree in a row, assuming that the trees are evenly spaced. A golf course architect has 4 linden trees, bald cypress trees to plant in a row along the fairway. I believe it's going to be factorial because there's a whole lot of different ways you could do these. You could do every one of these, every one of these, every one of these, and you could do every one of these, every one of these, every one of these. So I would highly suggest it be factorial. We're going to check. Yep, same problem. And since you got 2 or 3 that's repeating, you're going to have, in this case, you're going to have the 2 that's repeating. Let's see, how many we got? We got 5, 2, and 4. So what's 4 plus 5 plus 2? 6 and 5 is 11, so that's going to be 11 factorial. And then you're going to have 4 that's repeating. So that's going to be 5, 4 factorial, 5 factorial, and 2 factorial probably. Chances are. This must be a new, yeah. There it is. 11 factorial over, yeah, be 11 factorial over, if I could ever get there, 11 factorial over 4 factorial times 5 factorial times 2 factorial. Again, that's one that we have not covered. That's my fault. I didn't know they were in there. I guess that's why I'm getting these questions, because they were in there and y'all went over them and I didn't know they were in there. So this is number 19. The grade appeal process at a university requires that a jury be selected by selecting 7 individuals random from a pool of 12 students and 12 faculty. What is the probability of selecting a jury of all students? What is the probability of selecting a jury of all faculty? What is the probability of selecting a jury of 3 students and 4 faculty? This looks like a combination. I'm not sure yet. So we've got how many? 12 students and 12 faculty. What is the probability of selecting a jury of all students? What is the probability of selecting a jury of all faculty? What is the probability of selecting a jury of 3 students and 4 faculty? I believe we're going to be using a combination here.
Gmail.
Yep, combination. Just want to make sure I was right because I haven't seen this one either. So, in this question, it says, selecting individuals for a pool of 27 students and 30 faculty. So we're going to add 12 and 12, so that'd be 24, right? So N is going to be 24. And then you're going to pick, what's the chances of it being 12, 12? So that's the first two. A and B is going to be 12 combination of 12. It should be 24, sorry. So that'd be 24 combination of 12. 24 combination of 12. Should be the same thing. And then the other one's going to be, I want to make sure. Yeah. And then the next one, it says, given that the jury 10 members combination rule, calculate the number of juries that can be made from one, blah, blah, blah. I want to make sure I'm doing that right. Yeah. What is the probability? No, C. I want to get to C because that's the one. C is going to be, it should be multiplying the two together. So 27 of 4, what is the probability for, and 6? So it's going to be 24 combination of 4 and 27 combination of 6. You're going to multiply them together. And then you multiply them. Yep. So that's what you're going to do here. So on this one, you're going to have 12 combination of 12, 12 combination of 12, and then this one is going to be 3, or 24 combination of 3, and 24 combination of 4, and you're going to multiply those two together. Did you get that? So those are combinations. First one's 24 combination of 12. Wait a minute, let's make sure. How many is there 12 on a jury? The grade appeals process that is requires that the jury be selected by selecting 7 individuals from, okay? So that's going to be 24 combination of 7, and then 24 combination of should be the same because there's 12 students and 12 faculty. So A and B is going to be the same. What is the probability of selecting a jury of 3 students? That would be 24 combination of 3 times 24 combination of 4. So, not a test question. And the last one, a certain organization recommends the use of the passwords in the following format. Oh my God. Consonant, vowel, this is ridiculous. Consonant, vowel, oh my gosh, consonant. Now you got to figure out how many consonants are there. Well, in vowels, we'll just do vowels. How many? There's 5 vowels and 21 consonants. How many letters are in the alphabet? 26. So you know your N is going to be 26. How many slots do we have? 1, 2, 3, 4, 5, 6, 7. Right? No, 7 slots. Okay? Now for the first 6 slots, we know we're going to use a combination of one of these. So it'd be 26 combination 21, 26 combination 5, 26 combination 21, 26 combination 5, 26 combination 21, 26 combination what? 21, and then what's this one? Okay, well the numbers have to be where? I guess 0 to 9, right? That's 10. 10 combination 1. And then you multiply all those together. Assuming that the passwords are not case sensitive, how many passwords are possible? It's going to be a BA number. Okay? I'll write that down for you. Wait up. I'll write that down for you. This right here, Okay, each slot is going to be n is equal to 26. N is equal to 26. Dot, 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 dot. And here, n is equal to 26. Here, n is equal to 10. Why? Because all numbers go from 0 to what? 9. So that's 10. Okay? And here, your r is going to be consonant 21. 21. 21. 21. R is equal to 1, because in this case, you're only going to pick 1. Okay? And here, 5, R is equal to 5. R is 26. 26. R is equal to 5. Like that. And then you're going to multiply each one of those. Multiplication, 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 multiplication. That's going to be a big number. Does anybody ever ask for consonant, vowel, consonant, vowel, consonant, vowel, consonant? No, nobody. That's why I didn't use it. I wouldn't use it. I'm going to use the lottery question. I'm going to use the board member committee question, the trifecta question, and I might use the smile or king, which is 5 factorial and 4 factorial. Why do I pick those? Because those are what I see on standardized tests. I've never seen these questions that y'all sent me today. I've never seen those questions before, so those have to be new questions that the publisher has just put in to the MyLabs Plus. So y'all forgive me on that, okay? I'm not a water walker. Any questions? That takes care of those questions, I hope. I hope you can work your way through the muddle your way through those. Now, let's go over new stuff. So let's go to our handy dandy. And I don't want to go over new stuff, but I have to, because if I let y'all go early, somebody will complain. So what's the number one rule of life? There's always what?
One.
There's always one.
Well, there's only 4 today.
You just don't understand. It doesn't matter how many's in the class. There could be 300 in the class. There could be 5 in the class. There's always one that's going to go against everything. Y'all got to remember that. You don't know who it is. You don't know who it is because those are the ones that go to your boss or your supervisor. But what do they tell them? Don't tell them it's me. .mylabsplus.com. Listen, it would do me just to cancel class on Monday, Tuesday, and Wednesday and just have the whole week forethought. But I know somebody, yes, I just wanted to let you know that Hubert canceled all his classes this week, and I thought you might want to know that. That's exactly what would be said.
So we're off Thursday and Friday?
You didn't know that.
I figured it was either Wednesday or Thursday.
You know what I ought to start doing? I ought to start sending y'all an academic calendar the first week of class. That's what I should start doing. Get y'all to print it out, put it in your notebook. I ought to start doing that.
I already have that, but
I did. I sent that. He didn't print it out. He didn't read it. He didn't put it in his freaking notebook. And he would be the exact one to show up here, walk through an empty parking lot, empty hallway, and come to the empty room, and then go back to the information desk and say, "We don't have a class today." He would be the one. Now, I'm going to pull up the handy dandy. Oh, look, it's even on here. Look at there. Look at there. Oh, my gosh, there it is right there. Outline. Let's see what we go over next. Unit, what, 3? 80% of your test is going to come from this section right here. 7.2. 80% of your test. And this test will cover 6 and 7. I'll leave 8 for Unit 4. Okay? So, this is your shortest test. Okay?
It seems like we would be taking it soon, right?
What?
It seems like we would be taking it soon because it's like, what, month of class?
Yeah, but this is going to be short and sweet.
Yeah.
the 6 and 7 will be short. Okay, so let's go to 6 and 7, and let's go there and tell you what we're going to be going over. Was it 6-1, 6-2, 7-1, and 7-2? Was that what it was?
Yes.
Let me go back and look. I forgot it all. 6-1, 6-2, 7-1, and 7-2. So 6-1. I'm going to pull out what's important. I'm going to go to the well, if I could find the e-text, because there's only 2 or 3 formulas that you need to know out of chapter 6. Okay, I just want to make sure. And chapter 6, 6.1. Make sure you write down 297, those two numbers, a discrete random variable and a continuous random variable. A discrete random variable means that you're counting the whole numbers. A continuous random variable means that you are counting not only the whole numbers, but you're counting the decimals in between the whole numbers also. Okay? And that's pretty self-explanatory because we talked about that. Discrete means measured. Continuous means measured. Discrete means countable. Discrete is how many eggs are in a carton. Okay? You can't count 1.2 eggs in a carton. It's 1, 2, 3, 4. Versus, how tall are you? 5 feet, 5 inches. Okay? That's in between 5 and 6. Okay? It's in between. So make sure you write that down because this section is based on whether it's a discrete or whether it's a continuous random variable. And basically what we're going to be doing is figuring out the mean and the standard deviation of a probability distribution. Well, what is a probability distribution? There it is right there. That right there is a probability distribution. I want you to write that down as an example because what's the difference in it and a frequency distribution? Well, the frequency distribution gives you a head count. What does a probability distribution give you instead of a head count? A probability. Think of it like this. Some of y'all are baseball fans. I never have been a baseball fan. I'm sorry. I just don't get into it.
I find it boring.
I do. I much rather watch golf, and I used to watch NASCAR until they messed up NASCAR. And I
Hear
won't
about that
watch it.
picture?
Huh?
That picture that died yesterday?
Yeah, I heard about that. That was
what
awful.
he said. They didn't say why or how.
Wow. What team do you play for?
The Angels.
Yeah, I heard it this morning on the news. That's awful.
What was his name?
And then one was shot in Dominican Republic where all them people are dying. I don't think I'd put Dominican Republic on my vacation list.
Yeah, a lot
At
of
least I'll drink my own liquor when I take my own liquor down there.
yeah, a lot of them are from there, and like every off season, there's like some rig or someone.
It sounds like to me, you know what it sounds like to me? It sounds like to me that they're bootlegging the liquor and keeping the real liquor for themselves and putting in the substitute. I think that's what they're doing.
Seriously.
I like that country because they allow me to drink.
Oh, okay. Yeah, go down there and die. In Appalachia, it's called rock gut. You got lead in the moonshine or the alcohol because you use lead pipes and lead radiators and stuff like that. And that's where you get, and you basically die.
Where is the Dominican Republic?
Is it in the Caribbean?
Yes, it's in the ocean. That's all. It's one of those places that you couldn't get me to go to.
See, my philosophy, there's the ocean between us for a reason.
Yeah, and I guess I'm just redneck, but when you travel to places that I've traveled, I could care less about going to any of these places. Now, I don't mind going to Panama City, and I don't mind going along the coast of, the Gulf Coast. I like that because you can see what's fixing to eat you. A shark comes up to you to eat you, you can see it coming. In the Atlantic, you have no idea it's coming. But at least down there, you can see it. All right, I'll shut up. All right, for some of you, how do we get baseball to sharks? Anyway, baseball game. What is the what is the probability that the hitter is not going to hit a single hit? What is the probability that he's going to hit one hit? What is the probability he's going to hit 2 hits? What is the probability he's going to hit 3 hits? Okay, that's how you read these probability distributions. This is the account. He's going to hit 0 hits, 1 hit, 2 hits, 3 hits. Here's the probability. Okay, now I'm going to show you how we get this in just a minute. But I want you to understand what we're actually looking at. Now, in order for a probability distribution to be a probability distribution, you have to do it take it through this test. Right here is very important. That's the test. The probabilities, and y'all know this, the probabilities have to equal what? 1. If you add up all the probabilities, they have to equal 1, and each probability has to be what? Between 0 and 1. As we said before, I think on that last test, it asked you had a negative number. Can you have a negative number? No. Can you have a whole number? Well, you can have 1, but you can't have like 2.5. You can't have 2. You can't have 6. You can't have negative 5. You can't have negative 1/3. It has to be equal to 1. All of them equal to 1. All of them added together equal to 1. And it has to be between 0 and 1. Capiche? Okay. I get the feeling that y'all just not in it today. Why do I get that feeling? Okay. What? Okay. Here is 3 examples. Now this first one is not a probability distribution. It has a negative. Okay? These, I don't know. Let's see what they say. Not equal to 1. These do not equal 1. This one probably is. Okay? So that's a test question. Is this a probability distribution? You should get that one right. Okay? How do you find a probability distribution? Well, I'm going to do it real easy for you. Okay, I'm going to take my whiteboard and I'm going to show you how a probability distribution is created. Let's take, for example, a couple having 2 children. Or let's go with, 2 children. All right? Couple having 2 children. And there's all these different, when somebody's going to have a baby, they always do these different, they either look into all these health studies, or they look into all these experiments, or they ask their doctor for different, to have 2 girls or 1 girl, or, selection. Okay, so, and this is a question. Some people, it has been determined that people in this state have a probability of girls being 0.57 instead of what? What is the normal selection probability of a girl? 0.5. But they're saying in this state, blah, 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 whatever state you're talking about, or in this county, or in this, this doctor's office has found that our patients have, whatever. They'll tell you this, okay? They want to have 2 children. So what is the sample space of children? Boy, boy. Girl, girl. Boy, girl, and what? Girl, boy. So, oops, that's wrong. Well, I'll just do this. Okay, this is 0 girls. Probability of a girl. 0 girls. What are these? 1 girl. So I'm going to erase this right here, and I'm going to put 1 girl. And what is this? It's 2 girls. So there's our probability. Probability of 0 girls, 1 girl, and 2 girls. This is how you make a probability distribution. Okay, here I'm going to put outcome. And now I'm going to calculate. Now, you don't need to know this for a test or a standardized test. It's just something you need to know. Okay? Because when you see these weird probabilities, this is how you come up with it. All right? So boy, if the probability of a girl is 0.57, what's the probability of a boy? Point what?
0.43.
0.43, right? I just heard 0.3. I don't know where I heard that. Now, a lot of people say, well, why didn't you cross out the not a girl? Because you're only born one of two genders. Okay? I don't care what anybody tells you. I don't care where you get your information. Okay? If you don't know what gender you are, it's real simple. And that's all I'm going to say. All right. Now, you take that 0.57 and 0.43 and you're going to calculate it over here. So here, it's going to be 0.43 times what? 0.43. Because you're what? You're multiplying. This is going to be 0.43 times what? 0.57. Somebody be calculating these, please. This is going to be 0.57 times what? 0.43. And this is going to be 0.57 times what? 0.57. So somebody calculate those for me. Of course, these two will be the same because multiplication is commutative. And this is probability of the event, which is probability of girls happening. So what is 0.43 raised to the second power? What is that?
0.1849.
48 what?
1849.
Okay, somebody do these two. What is 0.43 times 0.57?
0.2451.
Point what?
0.2451.
And what is 0.57 squared?
0.3249.
0.3249.
49.
Now add those up. What should you get? 1. Add them up. Now I'm going to take my handy dandy green highlighter and I'm going to highlight this column and this column, because on a probability distribution, what do you see? These two columns. This is how you get those two columns. So you might want to put that in your notebook, your handy dandy notebook. That's how you get a probability distribution. Now, on a lot of these questions, they're just going to show you the green on the left and the green on the right. But that's how you come up with, you've got to be given a probability. Now, what if you wasn't given a probability? Well, then it would be 0.5 times 0.5, 0.5 times 0.5, 0.5 times 0.5, 0.5 times 0.5. You don't do it. It's when you're given a different probability that, or an actual probability that exists, you know, in real life. That's what it's made off of. Capiche? So in 6.1, when you see these probability distributions, that's how you find them. Okay? We already covered this. Summation of the x's, summation of this divided by n. You know how to do that. That's your test scores. You take these numbers and divide by. I'm not going to go over that. That's ancient history. We're not going to go over that. Go ahead and write that down. The mean of a discrete random variable is the summation of x times what? P of x. We've already covered this. Instead, it was x times f. Remember? Probability and frequency distribution, they use the same type formulas. So that's important. So how do you find this one? Well, 0 times this is 0. 0 times this, and then you add them all up. Pretty simple. Now remember, what are you doing? You're finding the mean. Okay? So read this. I just want to read this. I'm just picking this question because it's in front of us. Compute the mean of the discrete random variable, blah, 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 blah. What is this? Or does it give us... this comes from some... table 1, it comes from something else. Where does it come from? Hold on. Free throws. That's where it comes from. So it must be a question on the first page. Okay, it has something to do with free throws. I don't know where it comes from, but it's free throws. All right. So the probability. I want you to read the probability distribution. Where is it? Have we?
It's to the left of the question.
Thank you. Compete the mean. Okay, it says the probability of 0 free throws is 0.01. Probability of 1 free throw is 0.10. The probability of 2 free throws is 0.38, and the probability that you're going to get all 3 free throws is 0.51. Does everybody understand that? So what does it mean when you get the mean? Well, when you get the mean, it says basically the first 2 columns represent find the mean, discrete random variable, blah, blah, blah. It says find the mean number of free throws made. So given just the number of free throws and the probability, how many free throws are going to be made? 2.4. 2.4 doesn't mean anything as far as what? Free throws. It's either going to be 2 or 4. In this case, it's going to be 2 because it doesn't round up. So it'd be 2. Your mean is 2.4 free throws being made. So you could say blah, 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 basketball player makes 2.4 free throws per game or whatever because you took just this information. Well, what's different about that? Well, before you took test scores and found the mean, and you took a frequency distribution and found the mean. Now you're taking a probability distribution and you're finding the mean. So remember, what are the most important numbers in statistics? Mean and standard deviation. So that's why you got to find these things. All right? And they're going to give you another formula here in just a minute to find the standard deviation, hopefully. And they're going through and doing this, expected value. I'm looking for the, there they are. All right, write this formula down. I use the second formula, okay? So I write down the second formula, make sure you write it down. The standard deviation, what is the standard deviation also? The variance, right? The variance is what's under the radical. The standard deviation is the radical. Everybody with me? X squared times P of X. Oh gosh, we got to do X squared again. Where do we know that from? The frequency distribution. Taking X squared and squared. In this case, it's not going to be a midpoint. It's going to be 0, 1, 2, 3, 4. You're going to square 0, 1, 2, 3, 4. Okay? So write that down. X squared times the probability minus the mean what? Squared. So you're going to take the mean and you're going to square it and use it in the formula for the variance and the standard deviation. So in 6.1, you've got to know 2 formulas. You got to know the mean, and you got to know what? The standard deviation, or the variance with the standard deviation, whichever one you want to call it. And you got to know the test. All the probabilities have to equal what? 1, and each probability has to be between what? 0 and 1. Now, look on the next page. I'm going to blow it up for you. Okay, well, here's the numbers I want you to... I'm trying to build up... Okay. All right, there's your numbers. Just kind of ignore... I could move this over. Yeah. Let me move this over. Okay, it's not going to let me, but I don't want you to just write down this right here. 0.01, 0.10, 0.38, 0.51. 0, 1, 2, 3. I'm going to write it down, and I want you 0, 1, 2, 3, 0.01, 0.10, 0.38, and 0.51. Because what I'm going to do is I'm going to go to the handy-dandy what? Spreadsheet. And I'm going to go down here, and I'm going to put in 0, 1, 2, 3. And then I'm going to put 0.51, 0.38, 0.1, and 0.01. Everybody with me? Now, of course, we need to check to see. So we can check and we see if that equals 1. And it equals 1. There's no negatives. There's no whole numbers above 1. So we've got a probability distribution. So what is this? This is x. And what is this? The probability of what? X. With a 9 instead of a. So what do you do to find the mean? What's the formula for mean? What do you do? The summation of what? X times P of X, Hubert. Thank you. I just told y'all 3 minutes ago. So X times what? P of X. So I'm going to take the first column and multiply by the what? Second column. And copy that down. And then copy this over. There's my mean. So I'm going to color that in a very bright lime color, so that will tell you that that's the mean. And you feel good about yourself. Now what? Well, what do we have to get the standard deviation? I said it.
X squared.
X squared. Good. We got to have x squared, so what am I going to do? I'm going to do x squared. Now I'm going to do it for you. I'm going to do it for y'all. Let's see. 0 squared is 0. 1 squared is 1. 2 squared is 4. And 3 squared is 9. I did that for y'all. You're welcome. Now what are we going to do with x squared now? X squared times what? P of x. X squared times P of x. Read the formula. That's all you got to do. So x squared, I'll do the first one for you. It's going to be 0. Times P of x. You know, it takes some students a whole year to figure that out. A whole semester it takes them. Hey, you just do the easy work. Yeah. Please tell me you're not married. Okay. But you're not going to procreate. Okay. X squared times P of x is supposed to be a joke. You don't have a driver's license, do you? You don't have a gun, do you? All right, and we're going to add those up. So take this, Control C. What? Control V. Now what? What does the formula say do? Let's go back to the formula, since you didn't write it down. What's the formula say? I use this one. X squared times P of x. Add that up, and then subtract the squared what? Mean. Everybody with me? So I go over here, go back to the spreadsheet. And I'm going to take this number, so I'm going to go down here and I'm going to call this the variance. Variance is equal to, well, I'm going to take this guy and I'm going to subtract, oops, sorry. Minus this number, what? Squared. So, here we go. 6.21 minus this number raised to the what? Second power. And that is your variance. And of course, since we've been doing since the first day of class, what do you do to get your standard deviation from your variance? Raise it to the 0.5 power, take the square root. Equal to that number raised to the what? 0.5 power. And that's how you find the standard deviation. So you might want to, write this down or take a picture of it. I'm going to make it a little bit bigger. I thought I was. Let me just make it bigger. Hold on. Let's take it up to, is that big enough for you? No, it's too big. I suck. Let's see, 20. Nope. Well, I could just take out 2 of these. Delete. Push those up. What the heck? Oh, I do. There. Delete. Not hitting on all 4 cylinders today. There we go. Okay, can y'all? It's just one of those days. There. Okay, does everybody understand how to find the mean and the standard deviation? Well, that is a test question. So far, you need to know what? You need to know, how to test a probability distribution. You need to be able to, recite the formulas for the mean and the standard deviation, and you should be able to find the mean and the standard deviation of a binomial distribution or a probability distribution. I'm going to highlight these 2 yellow because that is what's given. So make sure if you're given a probability distribution that you can find the mean and the standard deviation. Capiche? I would let y'all go, but I think I'll let y'all go early. Even though somebody will complain.